everyone! Today we're going to be learning one of the coolest concepts in life contingencies, the multiple decrement model, with the help of Tom and Jerry. Because honestly, if there's anyone whose life involves a lot of decrements, it's Tom. But first, what is a decrement? In actuarial science, a decrement is a way someone can exit an active state into an absorbing state. An absorbing state is one that cannot be exited, so something like death or permanent disability. For Tom, on a day-to-day basis, he faces three major decrements. Decrement 1, Spike the Bulldog. Decrement 2, Trapped by Jerry. Decrement 3, Explosions. So one might wonder, what is the probability of Tom decrementing through Spike, or say Jerry's traps, or even explosions? Well, we have notations for just that. The probability of Tom exiting state 0, which is when Tom is alive, into state 1, decrementing through Spike, is TP101, since Spike is in state 1. The probability of Tom exiting state 0 into state 2, which is Jerry's traps, is TP102. And then the probability of Tom decrementing through explosions from state 0 into state 3 is TP103. Tom is age 1 in cat years. That's why we have TP1. If Tom was age 32, we would have TP32.
So now we're going to be calculating some probabilities using our multiple decrement table. First, let us calculate the probability that Tom decrements into state 1 in 1 year. So we have the 1 here, since it says 1 year, and then the 1 here represents Tom's current age. The 1 here represents state 1, and the 0 here represents the state Tom is currently in, which is state 0 since Tom is alive. So to do this, we can simply do D1 1 over L1. This gives us, picking up the numbers from here, 50 over 1,000
which equals 0.05.
Next, let us calculate the probability that Tom decrements into state 2 in 2 years. So we have the 2 here to represent the 2 years, 2 here to represent state 2, and the 1 here to represent Tom's current age. We can write an expression down for this probability. So we have P102. This represents the probability that Tom decrements into state 2 during the first year, plus P100. This represents the probability that Tom survives the first year, and then P202 to represent the probability that Tom decrements into state 2 during that second year. We can write down this as D12 over L1 plus L2 over L1, L2 here, and then D22. Notice that we can get rid of these L2s here, so that just leaves us with D12 plus D22 all over L1. So picking up the numbers from that table now, L1 is 1,000, D12, and then D22, so that's 70 and 40. All over 1,000. That gives us 110 over 1,000. That's our final answer. Let's calculate the probability that Tom is still alive in 2 years. So we can write that down as 2P001. 1 is Tom's current age, 0 is the state that Tom's currently in, and we want the probability for Tom to be in state 0 in 2 years. So we can just write that down as L3 over L1. Picking up the numbers from the table, get 670 and 1,000. .67. Lastly, let us calculate the probability that Tom decrements due to explosion between ages 2 and 3. Recall that explosions is state 3, So we can write that down as 1P1P103, and then that probability can be written down as that expression here. So P100, which is the probability that Tom survives that first year, and then P203, which is the probability that Tom decrements into state 3 during that second year. So solving this now, times D23 over L2. As you can see, we can cross these two out, and then we're just left with D23 over L1. Picking up the numbers from the table again. So D23, 30, and then 1,000. This gives us 0.03, which is our final answer. Here are all the probabilities that we calculated. Thank you for watching this video.